Hello everyone, my name is Mariam Jabadwala, working as Assistant Professor for Department of Information and Technology, Vidyavardhani's College of Engineering and Technology, Vasai. In today's video lecture, I am going to explain you the concept of broadcasting in numpy array. Let's move ahead. So in last few video lecture, we already discussed about how to create numpy arrays and the attribute of numpy array. We already discussed about 6 attribute of numpy array in last video lecture. That is name attribute, shape attribute, size, item size, d type, and n bytes attribute, and two methods defined in numpy array class, that is reshape and flatten method. Hope you understand all this point well. If you are not able to understand this, then please see my previous video lecture to understand all this concept, right? For broadcasting, you should understand what do you mean by the shape attribute, right? So shape attribute is nothing but the rank of the matrix. For 1D array, the shape is nothing but the number of attribute in the array, right? And for 2D array, if you remember, the shape is nothing but the number of rows and number of columns present in the array. And for 3D array, 3D array is a combination of multiple 2D arrays, right? So for 3D array, shape attribute will give three argument. The first one is the number of 2D array, second one number of rows in each 2D array, and third one number of column in each 3 array. So this is nothing but the rank of the attribute, right? So shape attribute will always give the rank of the attribute. So let's understand the concept of broadcasting in numpy array. So the term broadcasting refers to the ability of numpy to treat arrays of different shapes during the arithmetic operations, right? As we all know, arithmetic operation on arrays are usually done on corresponding element. Fine. If two arrays are of the same shape, then these operations are smoothly performed, right? If in mathematics you know the array multiplication, addition, subtraction, division, all the arithmetic you can perform on matrix, right? Or in 2D array. So if the shape of 2D array, if the shape of two, input arrays are same, then it is very easy to perform all the arithmetic operation, right? For this, we just checked one programs 47.py, right? If I want to apply the arithmetic operation, then what happen? We'll check in 47.py program. In this program, I declare one 1D array. Let's start notepad, right? And the name of the program is 47.py, right? So here I'm importing the numpy module. I declare one array, right? And B. So A and B both are the one dimensional array, right? 1D array, and both are compatible, right? 4 elements are present in each array, 1 row 4 column, 1 row 4 column. So we can apply any arithmetic operation easily over here, right? Suppose I'm writing C is equals to A into B, so print C will print the result, means how it will perform the multiplication. Corresponding element multiplication will be take place, 5 into 90, then second element of C array will be 7 into 50, then 3 into 0, it will be 0, and then 1 into 30, right? So let's run this program. Name of my program is CLS. I write first, and then 47.py is the name of the program, right? So here the output is nothing but the multiplication of corresponding element present in the array. So this is very simple program. What I want to say here is, if you want to perform any arithmetic operation and the shape of arrays are similar, then it's very easy to perform all the arithmetic operation. Here A and B are single dimensional array, and suppose A and B are multi-dimensional array with the same shape, then you can perform any arithmetic operation easily, right? But sometime what happen, the shapes of two arrays are this similar. So for operation on arrays of non-similar shape is possible in NumPy, right? If we want to perform a non-similar shapes of arrays arithmetic operation in using the simple array module, then system will give you array. But NumPy is having this facility. NumPy will provide the broadcasting facility, means a smaller array is broadcast to the size of the larger array so that they have a compatible shape, right? So broadcasting numpy array, I can explain using this figure. Right here, I write one array A with three element 1, 2, 3. And suppose I want to multiply with the scalar element, that is 2. So this is possible. So what is the result? 2 into 1, then 2 into 2 and 3 into 2. So what happened in broadcasting? This scalar element B, it broadcast to two more column, 2 and 2, so that the shape of this B, scalar element B, it will become the similar as the input array A. Means now both of the array are having the same shape, so that we can perform the multiplication operation or any other application, or any other arithmetic operation over here, right? So here element by element multiplication is possible. So I can explain this concept using 48.py program. So let's open 48.py. 48.py is the name of my program. So here I declare one array A, numpy array with three elements. This is a 1 into 3 dimension array, and print A, right? It will display the element A. B is equals to 2. B is a scalar element, right? And I'm performing C is equals to A into B. Means what? For B array, the internal broadcasting will happen. Means this 2 will broadcast to two more position, right? And corresponding element multiplication take place, and result is going to store in CR. So here the name of the program is 48.py. If you run this program, so this will be the output. It's very simple program, right? 1D array multiply by one scalar element, and here internal broadcasting take place in case of numpy array. And if you write similar program, without numpy array, then system will give you error, right? So say here, this is again numpy array. Okay, so next I will show you the concept of broadcasting rule. So what is the broadcasting rule? In order to broadcast, the size of the trailing axis for both array operation must either be the same size or one of them must be 1. This is the broadcasting rule in numpy arrays, right? If the trailing axis of both of the input array are same, then broadcasting is possible. Or trailing axis of one of the array is 1, then only the broadcasting is possible, right? And if the trailing axes are dissimilar, then broadcasting will not take place. And if this condition is not met, then the system will give us the error, right? And the size of the resulting array created by the broadcast operation is the maximum size along each dimension from the input array, right? So we'll explain this point using one example. Till now, if you are not able to understand broadcasting, then it is fine. We'll take some more example to explain you broadcasting. Okay. So here this figure explain a one two-dimensional array of size 4 into 3, 4 rows and 3 column, I'm going to multiply it with the scalar element, not with the scalar, with the single dimensional array. B means 2D array add with 1D array, right? So this is possible in numpy array using the broadcasting concept. Why? Because you check here the trailing axis. For A array, the trailing axis is 3, means 3 column, right? And here for the B array, the trailing axis is 1 row and 3 column, right? So 3, 3 is similar. 3, 3 is similar. So what will be the result? Result is 4 into 3, right? The bigger size. So what happened for 1D array here broadcast into 2D array, and the shape of this B array will become similar as the input array A, means here 0 1 2 is broadcasted to 0 1 2 0 1 2 and 0 1 2. One row it broadcast into 3 more rows, and total 4 rows are there now in B array size. So now how to add this? We add 0 0 0 with the corresponding element 0 1 2. So what will be the result? 0 1 2. Likewise here 10 10 10 add with 0 1 2, then result will be 10 11 12. Likewise the corresponding rows will be added, and this is my the result, and the size of result is 4 into 3. Okay, the same figure can be implemented using one program, that is 49.py. So I open 49.py here. This is my program, right? Here I declare one array. 2D array is there with 4 rows and 3 column, right? And one more array B. This is again numpy array with the 3 element, right? So their trailing axes are same. And I apply the C is equals to A plus B. So what will be the output here? Okay, so we'll run this program. Name of the program is 49.py. 49.py, right? So this is my output. The corresponding elements are added. First, B array will internally broadcast to 3 more rows, means total 4 rows are there with the same size, same element 1 2 3, again 1 2 3 1 2 3 and 1 2 3, right? And corresponding elements are added, and this will be my result. Okay, so hope you understand the concept of broadcasting, how to add 2D array with a 1D array, right? So 1D array is broadcast to the 2D array. Okay, so now this one is very important concept here. Suppose this figure shows what I'm going to add one 2D array with one 1D array. So what is the size of this array? Here dimension is 4 into 3, means 4 rows and 3 column, right? And I'm going to add it with 1 rows and 4 column. So check the trailing dimension. Here trailing dimension is 3 and here is 4, means trailing dimensions are this similar. So I cannot perform arithmetic operation on this type of arrays. To perform the broadcasting or arithmetic operation in numpy, the condition is the trailing dimension of two input array must be of same size, or one of the trailing dimension should be 1, then only broadcasting will be possible, right? So here a system will give you error if you write a program to add this type of two array, then system will give us a error, right? So I write one program 50.py, the system will give you error for this program, right? It will raise exception. Let's open 51.py program here. 50.py program here, right? So I import array. I create one array of size 4 rows and 3 column, right? And B array with 1 rows and 4 column. So trailing axes are mismatch, right? 3 here, the trailing axis is 3, and here for B array trailing axis is 4, right? So if I perform C is equals to AB, the print C will give me the error. Okay, to run this program, 50.py, right? So it will give you value error. Operand could not be broadcast together with shapes 4 into 3 through 4. Okay, so hope you understand this. So I already gave you all the programs, that is program number 47, 48, 49 and 50 regarding broadcasting concept. You just download all this program and try to execute it on your system along with this video lecture. You pause this video lecture in between and try to implement it so that you understand the concept of broadcasting well, right? You can change the elements over here and check your output and justify your output. Okay, hope you understand the concept of broadcasting in numpy array. Okay, so thank you very much for listening this video lecture. If you have any queries, then you can mail me on mariam.jawadwala@vcet.edu.in. Goodbye.